Hi everybody. I wanted to go through real quick the end of 7.2 just because I've had a couple of people send me emails and ask me how to do this because they're working ahead on the homework that's due on Tuesday. So if we look at example 11 here, it says that sometimes we don't want to find the proportion, probability, or percentile of a given normal random variable. Instead, we want to find the value of the normal random variable that corresponds with that proportion, probability, or percentile. So we're kind of thinking backwards. We're looking, let's say we already know the area, which is the same as the proportion or the probability, right? And we want to find the actual value, the z-score, or let's say the value of the random variable. So here we have, we want to find the z-scores such that the area under the standard normal curve to its left is 0.2. So I'm going to draw my normal curve, okay? I want the area to the left to be 0.2. So here's my mean right here. And since I want the area to the left to be 0.2, I've got to be over on this side because I have less than half my data on that left-hand side of the curve, left of my mean. So I'm looking for some area here, and I'm looking for a value for a z that equals something, okay? So what I'm going to do is I'm going to go over, and since we're looking at z-scores, I'm going to go into StatCrunch again, which was open a minute ago. Hold on here, let me find it for you. We'll look for Chrome. There we go. And I'm going to go to Stat again. I'm going to go to Calculators, down to Normal, and I'm going to open up my normal calculator. Here, we'll make it a little bit smaller. So here, because I'm looking for a z value, I'm going to use my standard normal curve. So mean 0, standard deviation is 1. Instead of filling out here where it says where I would normally put in my x value or z value, I'm going to leave that blank. Over here, I'm going to say the probability or the area is equal to 0.2. I want the left-hand side, so I'm good with the less than or equal to there. And I'm going to ask it to compute. You can see its graph looks a lot like mine. And what I have then is this z-score right here of negative 0.8416. So if we pop back over here, I have z equals negative 0.8416. Okay, so that's the area, the z-score where the area to the left is 0.2. If I want to do a similar thing to find the z-scores where the area of the normal curve to its right is 0.35, because I'm going to the right, and I want it to be 0.35. Again, here's my mean. I know it needs to be on this side, right, somewhere over here. And this area over here is going to be 0.35. So that's what this area is. That's my probability or my proportion. Remember, those are all the same. They are all equal to the area, okay? So I'm going to go back over to StatCrunch real quick. And instead, I'm going to delete this part out. I keep the normal standard curve with mean of 0, standard deviation of 1. This time I want to look to the right, and I'm looking for an area of 0.35. So I get a z-score of 0.3853. So if I come back over, I have z equal to 0.3853. If I want to find the z-scores for the middle of my distribution, the middle 99%, in other words, so I'm looking for what's my middle. Here's my mu. I want this part. It's kind of a funky looking curve that I drew there. So I want the area of this to be equal to, because my probability or my proportion is equal to 99%, so that's 0.99, all right? So that's 99% of the total area, which is 1. So I'm going to look at, I'm going to have two z-scores because I'm going to have some negative z-score over here, and I'm going to have some positive z-score over here. We flip back over to StatCrunch, and we're going to go to between. We're going to delete out the -1 and the 1, and we're actually going to put in 0.99. What we find there is I get -2.5758 and positive 2.5758. It makes sense, they're the same. It's a symmetric distribution, so it's equally laid out. Sorry. So I'm going to get -2.5758 and positive 2.57. Actually, let's write this a little different. Sorry, I'm choking now. So my z is between -2.5758 and positive 2.5758. We can do this a similar way if we look at example 12. Remember, if you remember percentiles, that means that 81% of the, let's say, samples or random variables, samples are at or below the value. That's the 81st percentile. Okay, so what we're looking at then is if it's at or below, I'm going to be talking about a less than or equal to. So this is my middle, so that's my mean. 50% is to the left of the mean. So I'm somewhere over here. This whole area, all the way down, okay, just less than whatever this value is right here, is going to be equal to, this area is equal to 0.81, sorry, which is 81% of my 1. Now I know this time I have a normal distribution with mean 50 and standard deviation 7. So we're going to change that on StatCrunch. So let's pop over there real quick, and we're going to put that in. So I'm going to come out of between. I'm going to go back to standard because I'm just going to want a less than. I want a less than. I had a mean of 50 and a standard deviation of 7. And I knew that my area was going to be, because I wanted the 81st percentile, oops, I went 0.81. So I went 0.81 to the left-hand side. I'm going to click compute, and what I find is for my random variable, I would want a random variable value of 56.1453. Come back over, oopsie, come back over here, maybe. So I want this x value is going to be 56.1453. So what I'm saying there is the probability that x is less than or equal to 56.1453 is equal to 0.81. So that's where my cutoff is to be in the 81st percentile. All right, you can use a similar approach for example 13. I'm not going to go through that. I want to talk really quick about this z sub alpha. The z sub alpha is a z-score where the area underneath the standard normal curve to the right of the z sub alpha, whatever that z value is whatever the alpha is. So here, if I'm looking for this z sub, well, let me give you a different example. If I were to look for a z sub 0.05, okay, we'll pick our unusual number. What I'm looking for then is that I want, if I look at my distribution, here's my mean, I want this little edge over here, this part. If this is z sub 0.05, then what I know is that this area right here is equal to 0.05. So it's about 5% of my area. Not too hard to find, right? If we go back to StatCrunch, again, we love StatCrunch. We're going to go back to the standard normal distribution again. So I'm going to do a mean of 0, it's right in the middle, and a standard deviation of 1. This time I'm going to delete off this. I want the greater than because I want that right tail. And I want that to be 0.05. So I'm going to pop that in there and I'm going to compute and I get a z-score of 1.6449. So come back over here. I'm going to say that's equal to 1.6449. Okay, and you can do the other two here. You can do A and B exactly the same way that I just did that. You're just going to look for the area in the tail to be 0.01 with this one and 0.025 for the second one. All right, so it's not too bad. If you have questions on those, this is really just if you worked ahead, and that takes you to the end of 7.2. I wanted to go over it just because I had several people who were working on 7.2 for Tuesday, and I've been asked several questions. So I thought I'd put together a really quick video and help you out. I hope you have a great day. Let me know if you need anything else, and I'll see you soon. Bye bye.